Have you ever pondered about the uncanny ability of computers to process intricate operations in just a millisecond? Welcome aboard the intriguing universe of algorithms, the secret recipe behind the enchanting and ceaselessly evolving field of computer science. Plunge into the heart of a computer, and you'll witness algorithms actively at work, tirelessly solving complex issues, deciphering perplexing and making sense of the digital chaos that seems so overwhelming to the untrained eye. What is this mysterious element driving the digital wonders we see around us? What is this elusive set of rules that create the magic behind the screen? Algorithms, the unsung heroes of the digital realm, are the answer. But first, let's break down the term algorithm. Originating from the name of a Persian mathematician, Al-Khwarizmi, the term has now come to signify a series of operations performed to solve a specific problem or carry out a certain procedure. In its purest form, an algorithm is a step-by-step procedure for calculations. It is a carefully crafted sequence of instructions that a machine meticulously follows to achieve the desired output. Picture it as a culinary recipe that your computer uses to concoct the perfect digital dish. Every algorithm is a unique recipe, with its own set of ingredients, input, and a distinctive way of cooking, processing, to create a specific dish. Output. Algorithms are in our daily lives. From the search engine that rapidly finds the information you need, to the navigation system that guides you to your destination, algorithms are the silent warriors that make our lives easier. They are the architects of our digital experiences, analyzing countless variables and scenarios to bring us the most accurate and relevant results. But the world of algorithms is far from simple. It's a realm of complexity and nuance, where the most efficient algorithm doesn't always mean the one. It's a place where the smallest tweak can drastically change the outcome, and where the quest for perfection never ends. So, what is an algorithm really? Well, at its core, an algorithm is a step-by-step procedure for calculations. It's like a detailed recipe that your computer follows, careful not to miss a single step to whip up the perfect digital dish. To comprehend the significance of algorithms, consider this. A computer without an algorithm is comparable to a chef possessing all the ingredients but devoid of a recipe. Imagine a skilled chef armed with the freshest produce, aromatic spices, and a palate full of flavors. Yet, without a recipe, something as straightforward as making a pasta dish could turn into a culinary disaster. The chef could toy with the ingredients, mix them randomly, and hope for a perfectly balanced meal. However, the probability of creating a dish worth relishing is slim. The result might not only be unpalatable, but could also be a wasted assortment of valuable ingredients. This analogy mirrors the relationship between a computer and an algorithm. A computer, the chef in our analogy, requires lucid and pinpointed instructions to function resourcefully and effectively. Absent those instructions, a computer, despite possessing formidable processing power and vast amounts of data, would be as purposeless as our chef with a table full of ingredients but no guidance. In this context, algorithms play the role of the indispensable recipe. Algorithms, much like recipes, manifest in various shapes and forms, each tailored to solve a pertinent problem or execute a certain task. Some algorithms are simple and straightforward, akin to a basic pasta recipe you might follow for a quick lunch. An example could be the algorithm you utilize daily to sort your overflowing inbox by the date of the emails. On one hand, it's a simple process, but on the other, it saves you a lot of time by organizing your emails efficiently. Conversely, certain algorithms are incredibly intricate and complex, much like the recipe for a gourmet meal prepared by a Michelin star chef. An apt example of such algorithms are the ones that propel the world of artificial intelligence. These algorithms, despite their complexity, are designed to operate seamlessly and efficiently, breaking down complex tasks into manageable bits and executing them flawlessly. The complexity of an algorithm, however, doesn't define its importance. What truly matters in the realm of algorithms is efficiency. An efficient algorithm, irrespective of its complexity, can save significant amounts of time, decrease the probability of errors, and leverage a computer's resources to their fullest extent, thereby maximizing output. One might wonder how to gauge the efficiency of an algorithm. The answer lies in the fascinating concept of time complexity. Time complexity is a measure that evaluates the amount of time an algorithm takes to run as a function of the length of the input. It's an essential concept in the world of computer science. A comprehensive understanding of time complexity can empower you to write optimized, faster, and more efficient code. So you might be wondering, how does one design an effective algorithm? The answer is layered, multifaceted, and dependent on a variety of factors. It begins with defining the problem clearly and precisely. To understand the crux of the issue, we must pay keen attention to details and ask relevant questions. Once initial step is accomplished, the next phase is all about breaking down the problem into manageable chunks. This process, often termed as decomposition in computer science, helps in understanding the constituents of the problem, thereby simplifying the complexity of it. A good algorithm is a meticulously designed roadmap. Picture it like a recipe where each step is detailed and the sequence is carefully formulated to ensure a successful output. Tackling each chunk problem one at a time gives us the benefit of focus and precision. It's like solving a jigsaw puzzle where each piece has its place and value. The process of building an algorithm is not linear. It involves an iterative process of trial and error, testing, refining, and improvement. It's about creating, failing, learning, and creating again. This cycle of development continues until you've got an algorithm that does exactly what you need it to do. However, it's crucial to understand that the best algorithm isn't necessarily the most complex one. Complexity doesn't equate to efficiency. An algorithm can be simple and yet robust. Sometimes, the simplest solution, the most straightforward approach, can be the best one. It can save time, resources, and reduce the room for errors. There's an elegance in simplicity. It is this belief that encourages the pursuit of the simplest solutions. So don't be afraid to start small, to build from bare essentials. Each step, no matter how small, contributes to the larger framework. It's a journey, a slow and steady progression from a simple idea to a technically sound and functional algorithm. After all, even the most complex algorithms started as simple ideas. Every intricate system, every groundbreaking solution, every pioneering algorithm, they all have humble beginnings. It's the journey of these ideas, their evolution, their adaptation, their refinement, that leads to the creation of the most powerful algorithms. It is their ability to solve complex problems, their resilience, and their adaptability that truly marks their success. So remember, every journey begins with a simple step. In this deep dive, we've embarked on a journey into the fascinating universe of algorithms, exploring each aspect of these intricate mathematical constructs that form the backbone of the digital world we inhabit. The term algorithm might not be in everyone's everyday vocabulary, but it's essential to understand their critical role in the complex process of computing. Algorithms, at their core, are step-by-step procedural instructions that computers follow to solve problems or execute tasks. These tasks can be as simple as calculating the sum of two numbers or as complex as deciphering the genetic code in a DNA strand. Our exploration began with a detailed examination of the definition of algorithms. We highlighted that they are not just random sets of instructions, but precisely designed procedures aimed at achieving a specific result. Algorithms, the magic that power our digital world, turning chaotic data into meaningful information. Next, we ventured into the realm of time complexity, an essential tool used to analyze the efficiency of an algorithm. This concept helps to measure the time taken by an algorithm to run relative to the size of the input. We stressed the importance of designing algorithms with lower time complexities as it directly impacts the speed and efficiency of computers. Our dive then took us to the process of designing an algorithm. We emphasized that designing an algorithm isn't just about devising a method that works, it's about creating a process that does the job most efficiently. We highlighted the importance of simplicity in algorithm design and how this simplicity often leads to greater efficiency. We then examined the implications of algorithm efficiency on everyday life. We emphasized that behind each task you perform on your computer, whether it's sending an email, playing a video game, or writing a document, there's an algorithm working like a diligent backstage crew to ensure that your task is executed smoothly. So the next time you marvel at the speed of your computer, remember, Behind every click, every command, every operation, an algorithm working tirelessly to make your digital life a little bit easier. How's that for a secret sauce?